Good morning. I'm Jeff Hammond, Executive Director at International Ground Source Heat Pump Association. Thank you for joining us for the May IGSHPA Dig Deeper. We have an exciting topic this morning. I'll introduce our speaker here shortly. First off, we have just a few updates for IGSHPA members. And I also want to mention that this Dig Deeper is sponsored by Climate Master, manufacturer of water source and ground source heat pumps. We certainly appreciate the sponsorship. And let's take a look at what's the latest happenings at IGSHPA. A lot going on right now. All right, so if you are attending these webinars regularly, we'd love to hear from you. So many of you have great presentations that you could provide. So we are still accepting abstracts for 2024. If you go to igshpa.org, you'll find a button on the homepage that says Training and Events Calendar. Go there, and there's an abstract for submitting your presentation. We do have a few of those left, so if you're interested, please let us know. Next week is the IGSHPA Research Conference in Montreal. We have about 50 papers submitted, so it is going to be an exciting conference. A lot of information on new technologies and the latest research from really all around the world. We have just about all of the continents represented at this conference coming up. igshpa.org is the place to find out more. Also, our annual conference was pushed back a few months so that we would have a spring conference instead of December date. So our next conference will be March 11th through the 13th in 2025. We're partnering with the Geothermal Alliance of Illinois for this conference, and it's going to be in Champaign, Illinois, get the right city. You'll find details again at igshpa.org. Like the town halls and the Dig Deeper webinars, we are now accepting abstracts for our workshop speakers, so you'll want to get those in. Also, the hotel block, believe it or not, is already filling up, so we have almost 40% of those rooms blocked. There will be other hotels available once that block is full, but the advantage of being in the conference hotel is you can just walk over to the exhibit hall. In fact, we've reserved that entire entire convention for the conference, so we're pretty excited about that. Early bird registration's available, sponsorships are available, and we just opened up the exhibitor spacing yesterday. These are the sponsors we have for the conference so far. We could not do this conference without our sponsors, and we really appreciate all the effort and the support of IGSHPA for this conference. Likewise, we have people already exhibiting. This was just announced yesterday, as I mentioned. So you can see here we have quite a few people taking booths. This year we have an inside exhibit hall like you see on the screen, and we also have an outside area for heavy equipment. So we're expecting to get quite a turnout for this conference. If you haven't seen our Geo Outlook magazine, we have another issue coming out in July. The first one we had this year was in January. And we're doing 2 per year right now, moving to quarterly again, hopefully in 2025. We're partnering with BNP Media. If you read Engineered Systems or AHR News, you'll be familiar with BNP Media. So we have about 50,000 in our audience. If you want to write an article, let us know. If you want to advertise, let us know. It's a pretty big audience. So it's a great way to get your products and services out there. The new membership program I've talked about before on these webinars. Lots of changes to IGSHPA membership. We have discounts for members on certification. We also have new levels. So you'll want to check that out at igshpa.org, from directory only listings all the way up through benefactor listings. And we already have, I think, 7 benefactor members. We just announced this new member portal last month in April. If you haven't been to the member portal recently, you'll want to check this out. There's a whole bunch more information on the member portal. It looks similar when you log in, but you'll find a lot more information on your membership and your certification. So when you log in, you'll find expiration dates. You'll be able to do an auto renewal right online. Just put in your credit card, so that way each year or each 3 years, depending upon your membership level, you can just continue to have that re-upped. All of your certification information is online, right on that member portal. If you'd like CEUs for this Dig Deeper webinar, just send a message in the chat or Q&A. We'll need your email and your name, and we'll record those in the database. So send that in chat or in Q&A. We do have a new option for CEUs. If you're watching this recording, all of the town hall and Dig Deeper webinars are recorded. They're usually available a couple of days after the event. You'll find it on the IXPA website. So if this is a recording you're watching, make sure you provide this webinar code, and we'll give you credit for watching that recording. If you're live, don't worry about it. All we need is your name and your email address. So just a few housekeeping here. Items, just put your question into chat or Q&A, and when Jake is finished speaking, I'll read those questions and he'll have a chance to respond. There are some people who have had some difficulty with chat or Q&A, so if you see a message that looks similar to this, you'll want to accept the message so that you can chat. If you still can't use chat or Q&A, I will unmute your microphone. You'll be able to ask that verbally, but hopefully we're past some of those. I think most of the challenges in the last webinar we were able to overcome with Q&A if someone couldn't use chat. Just a quick disclaimer and a conflict of interest message, and then I will be happy to introduce our speaker. The upcoming presentation represents the opinion and the presenter and of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IXPA or its members. IXPA town halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. And with that, I'd like to again thank Climate Master for sponsoring this webinar. And let me switch over to Jake's slides. Pardon me one moment. Let's go into full screen and then I will introduce our speaker. We're thrilled to have Jacob Gribbon with us as our speaker today. He has over 26 years of sales, engineering, installation, and management experience dealing with hydronic, airside, and distributed refrigerant systems for commercial and industrial applications. He's third generation steam fitter by trade. He graduated from the pipe fitter apprentice and journeyman trades program in Southern California in 2004. Jake worked for two very large design build mechanical firms on the West Coast, starting in California, then eventually moving to Hawaii. He wore multiple hats during the installation, design, and management of the various system applications. These systems included geothermal, critical lab spaces, process piping for the Department of Defense, process piping for semiconductor and photonics facilities, process systems for classrooms, and traditional HVAC comfort, heating, cooling applications. From there, Jake was recruited by one of the premier rep firms on the West Coast as an outside sales engineer specializing in VRF technology, as well as supporting hydronic and airside products for various applications. He moved to Atlanta, Georgia in 2017 and took a position to work for one of the top VRF manufacturers in the world as a regional sales engineer for the Southeast. He was responsible for supporting applied reps with designs and education, as well as managing and growing owner-level relations. In 2021, Jake was then recruited by Climate Control Group to manage the Southeast region of the United States. He was responsible for managing sales for ground and water source heat pumps, air and water source modular chillers, as well as educating owners, engineers, architects about the benefits of geothermal and hydronic-based systems. Currently, Jake is working for James N. Pleasance, which is the premier applied rep in the Southeast. His responsibilities include strategic initiative, geothermal, hydronic, airside system support and education, as well as supporting building owner relationships. So with that, I'm happy to introduce Jake as our speaker today on GSHP's vital role in decarbonization. Whenever you're ready, Jake, thank you very much.
Appreciate it, Jeff. Thank you for having me. Thank you for Climate Master for sponsoring this webinar. Thank you for everybody joining today. It's a Friday leading up to a holiday weekend, so you guys showing up here means a lot, so I appreciate that. Jeff's going to help me out on the backside here. I was having some technical difficulties, so I appreciate that help, Jeff. Today, yeah, we're going to go over, some buzzwords, decarbonization, phase out of 410A, look into the past, look into kind of the future, what's coming up, and highlighting a few different systems, making sure, we understand the whole system application standpoint, the all-in costs, kind of more at a higher level higher level view of things, right? So Jeff, if you wouldn't mind going to the first slide, please. So we all know the buzzword decarb, right? Or decarbonization. And sometimes as an owner, we want to be decarbonizing, our buildings or decarbonizing our city, right? I think sometimes we got to really look back and remind ourselves what the actual definition of decarbonization is. I put that up here on the screen. It's reduction or elimination of carbon dioxide emissions from a process such as manufacturing or the production of energy, right? That's why this, the global initiative to go to lower GWP refrigerants is part of this decarbonization effort, right? And I think sometimes we need to step back, take that 30,000-foot view, get realigned, really get an understanding of what it is we want to do to these assets, how we want to design around them, how we want to communicate to them, communicate to the customers and really apply these systems, right? Another buzzword is net zero. Net zero really means we need to find ways to completely negate greenhouse gas emissions, right? And that's going to be tough. Definitely going to be tough, but we can definitely reduce greenhouse gas emissions, and this transition is a great step in the right direction. It's an achievable goal, and we can get there. And really, one of the biggest ways we can get there from a decarbonization standpoint and utilizing ground source systems, really, the governments recognize this, and they're giving out the huge incentives, right? The IRA. I think probably most of us on the call here understand the IRA and how great those incentives are to try to reduce greenhouse gas emissions and implement systems that will have a less impact on the environment, with also a very, very long life expectancy as well. In general, I'm going to be going over refrigerant transition, how this intertwines with decarbonization, as well as how it affects cost of ground source heat pump systems, right? So there's different ground source heat pump systems out there. How does it affect cost from an overall standpoint? And then in regards to this new phase out, and then also how does it affect and the overall cost of the building and the overall cost impact or the overall carbon footprint of that building as well. And I think you'll see, how this will be a little bit kind of eye-opening in a way from a decarb standpoint. So, Jeff, if you wouldn't mind going to the next slide, please. So I think we got to start by asking a straightforward question, right? What's driving decarb and the electrification movement in the first place? Obviously, number one is climate change, right? And then more specifically, by moving away from carbon fuels and utilizing on-site carbonless energy to heat and cool our buildings, we're helping, number one, get rid of the world's harmful emissions that threaten the environment of human health, right? We have family, we have kids, we have grandkids. We want the environment to be a great environment for the next generations, years to come, right? Number two, facilitating the zero carbon movement, and by taking advantage of the vast electrical infrastructure that already exists throughout most of the world. 85% of the world's population has access to electricity now, and the remaining 50% want it, right? The problem is that 40% of the world's electricity comes from burning coal, right? Fossil fuels. More importantly, burning coal to generate electricity accounts for 70% of the carbon dioxide emissions released into the environment. So how are we going to help reduce that? Many different ways. Ground source heat pumps really are a key way to get there. As far as global building stock, right, it's expected to double by 2060, further pressurizing the worldwide collective of decarbonization initiatives. So ASHRAE has put out some position documents out there stating that some of these global policies and commitments driving to this transformation in building design and performance are broadly motivated by climate change, and the global building stock, obviously, what I said before, is probably going to double by 2060. So in response to this, many countries, public and corporate entities have set goals to be carbon neutral prior to 2050, which I highlighted in my previous slide, that the carbon neutral net zero applications. So we got to really think about our designs and how we turn these commitments into goals by 2050 and really get those greenhouse gas emissions lowered across, these building life cycles. So let's go ahead, Jeff, and go to the next slide, please. So this 19-page document that ASHRAE puts out, that they put out, right, summarizes the proposed decarbonization strategies. Some of these strategies are developing technical guidance, standards, training, and other tools to support building decarbonization policy goals. One of them is to promote whole building life cycle assessments, support beneficial electrification of heating through education, information, dissemination, and focus training. A lot of communication and training, and that's really the essence of a lot of this of today, and what we need to be doing is industry leaders and organizations. Last but not least, advance HVAC and R technologies and practices that minimize the refrigerants' environmental impact while enhancing performance, cost effectiveness, and overall safety as well. Next slide, Jeff, please. So recognizing, looking at this slide here, we're going to look at, the whole. We can't just look at a building. We got to look at it from a holistic standpoint. Where's that power coming from, right? So many of you have probably heard of energy use intensity, or EUI, and that's generally assumed to be the annual total energy consumed by a building divided by the total floor area of a building. But the question we have to ask ourselves, is it enough to only measure what an operational building consumes within its very own walls, right? Otherwise known as site EUI. And I already gave you the answer here. The answer is no, right? So recognizing this fact that we can't just do it at the site, right? EPA has determined that source energy rather than site energy should be calculated and evaluated based on the energy usage of a building. So source energy incorporates all the transmission, delivery, production losses by considering all energy use. The score provides a complete assessment of energy efficiency in a building. So EPA has an online software called Energy Star, and it's a portfolio manager. Some of you have probably seen it. Maybe this may be new to some of you as well on this call. It's a no-cost web-based software, interactive energy management tool that applies the site source ratios to convert site energy units into source energy units for more equitable and realistic energy evaluation of buildings. So applying some of these ratios to building systems will really yield some eye-popping comparisons regarding heating, right? If you look at that table on the top left corner, you'll see building A, B, C, D, E, and F, right? ASHRAE really chose to focus on the heat pump technology, right? Is a critical strategy for decarbonization, which is why we're having this discussion today. With a coefficient of performance of 4, an electric geothermal heat pump consumes about 700 MBTU of source energy, compared to district steam, which is the next closest non-heat pump alternative, which consumes 1,264 MBTU of source energy. So let me ask you guys on the line here. I mean, ask you if this is a good deal or not. If you give me $1 and I can return $4 back to you, I think you guys would all be on board with that, right? So that's basically what we're getting with a geothermal heat pump system with a coefficient of performance of 4, right? It's a great deal. Next slide, please, Jeff. Thank you. So now that we've kind of highlighted, the full big picture of things, where we're going, we're going to dive deep, dig deeper, right, into 410A and this transition, right? These changes coming here that are already being implemented really are going to be a little bit bumpy, right? But I think with ground source heat pump systems, really, there's no reason why these systems shouldn't dominate really the commercial HVAC landscape. It's a no-brainer from energy standpoint, carbon reduction standpoint, and we really need to continue to push and educate the industry and ownerships on these systems. Right now, we're phasing out 410A. It's currently the most widely used refrigerant for the HVAC market, right? And it's a hydrofluorocarbon gas. I mean, the guys did a great job last month on the Dig Deeper, right? Explaining, really getting into the details of all the different refrigerants. And talking about the global potential rating, right? And everybody, I think, for the most part, has been hammered with this for the last year or so, right? We've all heard about it, and trying to reduce these greenhouse gas emissions, going from a GWP of 2088, which is what 410A is, right? Transitioning down to 454B and R32, which are both sub 700. And that's what the EPA is requiring us to be. So in general, what does this mean for us? I want to highlight a few different things and what this means for us moving forward. Next slide, please, Jeff. So this is the new next generation refrigerant. We're trying to decarbonize, reduce the amount of F-gas emissions used in this refrigerating equipment. This next gen equipment is considered by ASHRAE 34 mildly flammable, right? It's given the A2L classification. So to deal with that, right, we're going to we have new standards, new codes that are going to drive safety for installation of these systems, depending on what kind of systems you put in and apply to that asset. The biggest thing right now we all need to be aware of is these changes are actually already happening. Snap states are already implementing these changes. So as designers, we really should be designing around these systems, these low GWP systems right now. The other thing is that this transition doesn't just only affect mechanical contractors and equipment, right? From a equipment standpoint, depending on what systems we utilize, it's going to affect the structural, architectural, electrical controls, maintenance, and service of these assets, right? So from a decarb standpoint, that's critical as well. Jeff, next slide, please. This slide, I'm sure you guys have seen in various forms. This is kind of what the phase out looks like for 410A and other A1 refrigerants that are above 700 GWP. It's the beginning of an all more inclusive phase down of HFC refrigerants, right? F-gas style refrigerants. Over the next 10 to 20 years, the US and other adopters of this Kigali Agreement, which I'm sure you guys have heard of many, many times, will continue to enforce these progressively stricter limits on HFC production and consumption, culminating in roughly about 85%, in HFCs since 2011, 2013. So you can see that phase down approach. According to the EPA, by doing this, we're projected to phase down an equivalent of 4.6 billion metric tons of carbon dioxide, right? Our whole decarbonization strategy, equal to 3 years of US power sector emissions at 2019 levels. A global HFC phase down is expected to avoid up to 0.5 degrees Celsius of global warming by 2100. The wheels right now, everybody, I mean, it's in motion. We're seeing it globally. In the European countries, the good thing for us is European countries are a little ahead of the curve, so we can have some lessons learned from those guys as well. Nothing wrong with seeing what's going on and not trying to reinvent the wheel here. So you'll see me kind of highlight some of those things for us to consider. You also notice the progression of ozone depleting refrigerants to HFCs to HFOs, and then eventually to natural style refrigerants. 410A has been utilized in HVAC equipment going like on 30 years now, right? You can see that in another little graph. I kind of combine graphs, but you can see back in 96 is when 410A was implemented in the HVAC space. R22 was there. Being utilized in HVAC equipment. 2010, you can see, was the transition and the start of the phase down of R22 to 410A. And then you can see where we're going now. We're phasing down, and we're going to start implementing newer low GWP refrigerants. They've already started in 2024, but they're going to continue to be implemented up until 2026, right? The phase out. And then eventually to other even lower GWP refrigerants such as A3 style refrigerants, which are currently being transitioned to over in Europe, right? So from an overall big picture standpoint, we need to really, in my mind, look ahead even more so, right? I mean, I know we're all trying to get through just this first change, but understanding what's coming down the line even further. It could be 6 years from now, it could be 10. That's a very short window in the HVAC lifetime. So we just really need to look ahead on our designs and make sure the designs we implement in buildings accommodate for these policy changes once they do take effect here in the US. Jeff, next slide, please. Thank you. So here's some of that stuff that we can look at, right? Here's the EU progress under the HFC phase down set out in the EU their F-gas regulation. You can see they started 2014 was the last year before this regulation. You can see there's a spike there. But since 2015 up until 2022, it shows how the EU has started really squeezing and phasing these HFCs out, right? These F-gas regulations out. So it's a pretty cool little trend here to show you that it's actually happening. It's actually working, right? And they're having to adjust from an industry standard. Next, please. Next slide, please, Jeff. From an EPA timeline perspective, I just put it all in one spot here. This is based on the current EPA interim final ruling that came out in December 26 last year. This just shows the manufacturer compliance dates from our manufacturers implementing the new low GWP refrigerants and those compliance dates that have to be met, as well as the installation compliance dates that also were given by the EPA and with installation of this equipment. So you can see the chillers, your split system, your heat pumps, right? You'll notice that the heat pumps on the installation compliance date, so that's your rooftop units, water source heat pumps, the EPA considers those as a product. Therefore, coming off an assembly line in a controlled environment, the EPA is given a 3-year sell-through period of 410A systems. So that means that people who stock this 410A equipment right now can go through and sell that stock up until Jan 1, 2028 of the 410A systems. And that's all due to it being a concealed circuit from the factory and not something that's field erected out, out on the building itself. Next slide, please, Jeff. This one's kind of interesting if we look at it, everybody. Top right, we'll see that little window unit, right? We may have one of those in our house or a shop somewhere, right? I've seen them a lot of different places, even hotels maybe, right? But these window units, they've had A2Ls in them. They've had R32 refrigerant in them and have been in the US for quite a while. They just really haven't been nationally promoted, or they've kind of gone undetectable since the quantity of refrigeration in these systems are so low, right? If you look over to the left, I'm sure everybody is going to be heading there after this seminar, I hope, to the ice machine, get some ice and load up that cooler for the weekend, right? If we look at this, these are the ice machines we see at our gas stations, right? Or our Safeways or our grocery areas. They are already utilizing an A3 style R290 refrigerant, right? So, and that's been happening for a couple years already. So the U.S. isn't, the U.S. is already seeing these changes happen. We just haven't seen it really happen too much in the HVAC sector yet. If you look down the below left, you'll notice some of these cars. Maybe you guys drive some of these cars. R1234YF is an A2L. And so you probably didn't know that. Just a little fun fact there as well. So these refrigerants are nothing new to the U.S., right? They're just going to be starting to be implemented in the HVAC sector. So just want a little fun fact for you there. Next slide, please, Jeff. Moving on, taking a look at Europe and what's happening, I mentioned they're already starting to make the transition to A3 refrigerants and transition off F-gas policies, right? That we discussed a couple slides back. So you'll see R290, which is an A3, which if you read ASHRAE 15/2022 and some of these the new international building codes and new international mechanical codes, you'll see that they already make provisions for R290 in these safety standards, right? So it's coming. It's just a matter of time. And I think that window is going to come a lot sooner than expected. But, these systems they're going to be air source, right? And sorry, by the way, A3 style refrigerant is considered a flammable style refrigerant, if I didn't mention that earlier. So it's a propane-based refrigerant, natural refrigerant. And it has a global warming potential of about 15, right? And that's why they're really trying to transition to these refrigerants for decarbonization. But these manufacturers will have air source, but they're also going to have chiller style, ground source heat pump style systems, right? So we'll be able to use low GWP R290 style equipment with geothermal technology and have the ultimate net zero system utilizing these technologies, right? So it's very interesting to me. I'm excited to see when this stuff gets here. I know we still have to get through this current transition, but I don't think it'll be much longer before we see some of this other stuff. The biggest thing in my point getting across to you is we need to plan for this design now, right? We need to educate and plan for these new policies and this new equipment now in the U.S., right? So let's think big picture, communicate with our customers who we're doing this for, get an idea of how long they're going to keep that asset so that we can set them up for success. That's the biggest thing. So with that in mind, right, getting an understanding of the transition here, I'd like to really look at this from an overall big picture standpoint as well, and go into, this new A2L transition, what it looks like from an all-in cost of ownership, utilizing different applied systems that could utilize ground source heat pump technology. Next slide, please, Jeff. So you'll see total cost of ownership, right? And you'll see that I have the split systems, VRF, VRV, distributed refrigerant piping systems on the left-hand side, ground source heat pump systems in the middle, and your typical chill water systems. All of these systems can utilize ground source heat pump technology, right? Traditionally, VRF, VRV systems have been, from a first cost standpoint, really competitive with ground source or water source heat pump systems. If not, maybe just a little bit cheaper on the first install cost, after people understood how to install them, right? But due to these new standards, safety standards of ASHRAE 1522 and the international codes and some of the building codes that we're going to see incorporate these safety standards, some of these systems will be affected more just due to the mitigation measures that are going to be needed to deal with the A2L or mildly flammable style equipment. And so I'm going to just take you through some quick examples of each one of these applied systems you see here, and show kind of how that total cost of ownership will be changing and why ground source heat pumps really will be hard to beat from an overall cost of ownership standpoint. In addition to one of the top systems for decarbonization. Hope everybody's still with me. Appreciate you hanging in there. Next slide, please, Jeff. So if we look at a ground source heat pump system or a water source heat pump system, as I was mentioning earlier, it's a concealed circuit, comes off the factory assembly line just like a refrigerator, right? Roughly a 5-ton unit or smaller is not going to be required to have an RDS system or refrigerant detection system in it based on UL 240 guidelines. Obviously, as engineers and mechanical engineers and designers, we'll still need to look at the areas where these units will be placed in the areas they're serving and make sure we're compliant with those safety standards. For water-to-water type heat pumps, right? They'll be placed in a mechanical room or a mechanical closet because they don't have a means of diluting that refrigerant. There would be some cost increases to go with exhaust fans and a refrigerant detection system as well. So keep that in mind. You're still going to need to do your space area calculation. And then based on that, you may have to provide additional relay outputs to downstream components, dampers, alarms, et cetera, et cetera, et cetera, right? So as we look in forward, there will be some additional cost implications on these systems for water source heat pump systems for this transition that we're going to be seeing here. Next slide, please, Jeff. One more. Thank you, sir. So if we look at from an overall big picture standpoint, right now, if we had the office building you're sitting in or the office building I'm currently sitting in, right? Old water source heat pumps in it. We have 410A right now. We have that hydronic piping run throughout the facility. With these upcoming policies, right? All I have to do is if I have one unit that's met its life expectancy, I can shut off a couple valves, disconnect the electrical, and put that new low GWP equipment right back up in its spot, right? Still may want to do some calculations, make sure we're compliant, but from an overall standpoint, we're not going to affect the rest of the system, right? And if somebody doesn't have one style ready for me, I can go to any other style or manufacturer and get it and put it in that system, and it will work, right? So the nice thing about ground source heat pump systems, right, is that it's very flexible. from a highly flexible designs, from a TI build out, right? If we have a TI build out and it's not happening for the next couple years, but we have to get some stuff installed, then, then depending on when this transition happens, when you can get equipment, you can put a R290, maybe even an R290 in the future, right? So highly flexible for build outs, extremely efficient. We're getting our simultaneous heating and cooling. We're getting our independent zone control, and definitely less complex to design. Next slide, please, Jeff. If we look at what our other next applied equipment that can utilize ground source heat pumps, and that's our distributed refrigerant piping systems. Most of us may or may not know we definitely have to do calculations because it's a refrigerant-based system. Transitioning to A2Ls make it a little more difficult. There's a few more restrictions on it. So whereas we were designing around 26 pounds per 1,000 cubic feet, that has reduced greatly to roughly about 4.8 pounds per 1,000 cubic feet. The good thing is that there are great mitigation processes to allow these systems to be installed in a safe manner. Jeff, next slide, please. Right, there's additional mechanical ventilation systems that can be installed, additional alarm systems that can be installed, and then additional safety shutoff valves that can be installed as well in different locations. And I think some of the manufacturers will probably even incorporate these from the factory. So we just need to make sure we understand everything that's involved with these style of systems so that we can safely design it. Next slide, please, Jeff. And this is just an example of how we can mitigate utilizing safety shutoff valves to still install this style of equipment. Moving on. Next slide, please, Jeff. Third applied systems here is our water source chillers or ground source chillers. So we are able to use ground source technology for these applications as well. From an overall or from a mechanical equipment cost standpoint, we've typically had to have these refrigerant detection devices in these central plants already. So not much really has changed there, but we will still have to do some calculations on the space itself, because if we are below that RCL level or those refrigerant concentration levels in those particular machine rooms, we would have to refer to section 8.10, 8.11, and add in additional mitigation means if one of these pieces of equipment were to fail. Next slide, please. So let's go into some additional, we always look at the overall maintenance standpoint, right? But that I understand this is a after the fact deal, right, from a cost perspective, but I think it needs to be discussed up front, especially during this transition. For instance, if we have a customer that has a operating expenditure, they understand what that operating expenditure is year after year, and they have this template of building buildings the same way year after year. And we go through this transition with these different mitigation means that are needed based on the refrigerant change. And we don't educate them on that, and it becomes more and more. And we design a building the same exact way with that same equipment that they want. But they don't understand the additional equipment that needs to be installed for these systems, right? Their operating expenditures could go through the roof without them even really understanding or knowing. So let's make sure we really communicate on the actual back end side of these systems from a maintenance standpoint, because a lot of these things you see here in 10.5.3 in the periodic testing, detectors, alarms, mechanical ventilating systems, those are going to have to be tested and signed off on by the AHJs, whereas we never probably really had to do this before with 410A. So really understand where we're applying these additional means and methods of refrigerant, refrigerant mitigation, so that the owner understands what their operating expenditures are going to be on the back end. They may actually say, you know what, if we go with this other style system, we don't have all these same operating expenditures, so let's go a different way. All about communication. Next slide, please, Jeff. Again with maintenance, right? Again with maintenance, and I'm hitting you guys hard with maintenance here. If we look at the typical cost per pound, right, and I'm sure it's more right now, we're talking upwards of about $50 a pound for R410A. And I like to look at history, and I like to try to look into the future and really educate on both. So if we look at the left, you'll see a historical R22 price sell chart. As I mentioned before in the previous slide, some of the first slides, we transitioned R22. The transition was announced in 2010 to reduce R22 in systems and overall. If you look at that trend, you can see roughly the market. It took the market a little bit to react to it, but then roughly about 2012, look what happened to the price per cylinder, right, of R22. Everybody who's a service guy on this call may know that we call that liquid gold, right? R22 is liquid gold. Very expensive to get now. There are aftermarket refrigerants that you can put in there to try to keep those systems alive, but you need to really look at, what's that cost versus just putting a new system in. Over to the right-hand column there, we see our European trends due to their phase down. And this is the phase down we're going to be starting to go through, right? From 410A to 454B. So they announced the phase down, right? Started implementing it roughly 2015, which I showed you guys on that chart. Again, the market, it took a little bit for the market to react, but look at what happened roughly 2017. If you look at the percentage increase, we're by the hundreds, right? So that refrigerant had gone up greatly. So as we really educate these owners on systems, right, we really want to make them aware, not only from a cost standpoint of refrigerant, but from a decarbonization standpoint. We're trying to reduce as much of that HFC or those F gases in their building as possible, especially if they have huge carbon footprint needs or wants, right? So if we look at the trends here, these trends fall in line, and I'm sure we'll see the same thing here. As I've been given this presentation, I'm like, I'm going to go get, a pallet worth of this stuff and sit on it for a little bit and hopefully buy a new boat here shortly. So next 5 years. But let's go to the next slide, please, Jeff. This is one I've been just throwing out there. We may not see this for the next, I don't know, 2, 3, 4 years, right? This is one that I saw on, on some previous Dig Deepers, right? This was brought up really quick, but I think it's kind of the elephant in the room. We really need to talk about it or don't talk about it. So the general liability of these systems, meaning that they're classified as a mildly flammable, this new refrigerant we're using, right? Are owners going to have to carry additional insurance based on what system is installed in their building? Will installing contractors have to? Will engineers have to carry special insurance depending on what kind of system? So it's just getting an understanding in the liability things, right? Insurances are always a tough topic, but it's something I think we need to keep in the back of our minds and really get an understanding of. Next slide, please, Jeff. Jeff, how am I doing on time? How am I doing on time?
Let's see, we have about 10 minutes till 11:30 Central, and we do have a couple of questions, so I think we're still good shape.
Okay, great, thank you. Just give me a wind up here. So I'll continue to move this along. So from an architectural installation standpoint, right? I showed you water cooled chillers, right, or ground source chillers, mechanical rooms, and I mentioned section 8.108.11, right? So there could be additional architectural and installation costs from those. So just keep that in mind as we do some of these designs. Next slide, please. From a, oh, back one more, Jeff, I think may have, there, thank you so much. From a refrigerant standpoint, from a refrigerant-based standpoint, if we're doing split systems, VRF, please be aware, right, that, you know, per ASHRAE 15, 2022, you know, since these systems are classified, the refrigerants classified as mildly flammable, from a safety standpoint, right, they're requiring pipe shafts for refrigerant piping that penetrate 2 or more floor ceilings. And then also that fire resistant rated shaft, you know, depending on the building code, will be 1 hour rated, 2 hour rated. So, you know, we're adding additional costs, but we're also adding carbon, right? Talking to it from a decarbonization standpoint, in that definition that we talked about at the beginning, we're adding more product, which means more product, more processes, more manufacturing to actually get things installed for it to be safe, you know? So we just got to keep that all, you know, in the back of our minds as well. Next slide, please, Jeff. Highlighted a lot here, folks. Sorry about that. But so we have, if we have that pipe in those fire rated chases, if there is a refrigerant leak in those chases, obviously we need to do something with it. And per ASHRAE 15, 2022, we can naturally ventilate those shafts by doing some things. And then, or B, we can mechanically ventilate those shafts as well for these A2L refrigerants, right? In doing refrigerant detectors and having those makeup air fans turn on and off. So as we go through designs, again, additional installation costs, controls costs, you know, additional electrical, additional energy costs, right? So let's keep that in mind when we're talking decarb and talking energy efficient systems with ownership. Next slide, please. In addition, because of the A2L transition, there's been definitely a lot more leak testing protocols. Please keep that in mind. And then on the backside of some of these systems, if they have bigger systems containing 55 pounds or more, right, there's going to be some additional testing and signatures with certificates, making sure that all these systems have been installed properly. So for each system. So keep that in mind as well, please. Next slide. Thanks, Jeff. Signs and identification. This is out of ASHRAE 15, 2022. This is really nothing new to a lot of the chiller style installations, but from a split system side of things, just be aware that any refrigerating system erected on that premises, right, is going to have additional signage and find a location to put this, right? And then if it changes in any form, in any way, it has to also be that sign will have to be modified and reapplied and reset up. So this is just additional costs, additional things that we got to think about as we go through and educate owners on designs. Next slide, please, Jeff. I'm almost done, everybody. I really appreciate your patience. You guys have been hanging in there. So me, Jeff mentioned kind of my background. So I look at things from a 30,000-foot view a lot. And I'm taking this and trying to educate everybody here on decision making, right? If we look at an 18-month construction cycle starting today, right? We TCO the building in November of 25, right? That's right in the middle of a lot of these changes and implementations of different styles of equipment. So if we've set up an asset for ground source heat pumps, right, we've really set the owner up for any future policy changes like I've mentioned before. Depending on when these projects get programmed to when they get designed to when they get installed, right, we really got to look at all these other applied systems and make sure we don't put that owner at risk of having to go back and have a different system be implemented when, because of the timing of things. If we look out to the right a little bit as well, and I'm going to keep kind of harping on this, is, anywhere from 2030 to 36, there could be policy changes to start transitioning to A3s. That's not out of the question. That's why I educated and kind of showed you some slideshows on the A3s are here already. So let's look at when these buildings are going to be built. If we can look into the future and set these buildings up and these assets up and have a great, efficient ground source heat pump system, and really look at the decarb movement here, we'd really be setting these people up for success, these ownerships up for success, and doing the right thing globally. So, really, let's look at this both from a short-term and a long-term strategy. And then keeping in mind, right, with the Inflation Reduction Act and the tax benefits, along with the all-in owner costs, both first costs and operating costs, right, really sets the ground source heat pump systems up for the best decarb style system, really, that you can get. Almost done here, you guys. Thank you so much. Next slide, please, Jeff. So I'm just going to sum it up, right? So we need to educate as much as we can. Educate architects. Architects are typically the folks who have that direct line of communication with ownership, right? They will reach out to us as consultants, as engineers to get an idea of what should be happening. So we really need to give some good feedback, get educated, give some good feedback back to the architects to get with the ownership with, and make sure we ask some questions. What does the owner want to do with this asset? How long are they going to keep it? What are their goals for a carbon footprint? What are their ESG goals, right? Is there anything special they want to do? Really asking a lot of questions that will help us be able to design these buildings much better and give that owner something they are really going to be happy with for a long time. And then again, we're going to do our best. Maybe there's some ownership on the line right now. Educate owners on industry, right? And then going back to my last slide, right? Educate, well, you don't have to, Jeff, sorry about that. You don't have to, but just educate them on the timing of things, right? Educate them on the industry itself. I know we don't want to give owners too much influence, but it's really their building. They're paying for it. So kind of lay it out there for them on which way the industry's going, so they can make the right decision on which way they want to go. And then for all of us, last but not least, for all of us, just prepare for these new codes, new standards. Make sure we're implementing them properly. Ask a lot of questions, and make sure we understand the durations and deadlines depending on what system's chosen by you or your customer to design around, because that'll have an impact on the overall cost if we're not ready for that. And that's all I've got, Jeff, for today.
All right. Well, thank you so much, Jake. That was very informative, and my takeaway is maintenance and future proofing. So
future proofing, yes.
I think that's a huge deal. We do have some really good questions. We've got about a minute left, so I'll take a look at some of these questions, and if you're able to stay over, we can answer some of the others. It's your call.
Yeah, sure. I'll do my best.
All right, very good. So let me see here. The first question from Janine. She wants to know, what is the name of the software or website that measures heat to space and assigns site energy to get the source energy? You had a slide about source energy.
Yeah, I do, and that's on the EPA website.
Okay.
So that is, one second, I can bring that up. Give me a sec, Jeff. It's called Energy Star Portfolio Manager.
Energy Star Portfolio Manager. Okay.
Yeah.
So this webinar will be recorded. So if anybody wants to go back and listen to that again, they'll have that information. William asked the question, since the Montreal Protocol in the early 90s, it has been illegal to vent 22 or R410A. All of our trucks and service technicians have reclaimed bottles and reclaimed machines since then. So why does the government feel that it's necessary to reduce global warming potential by reinventing the wheel? It's embarrassing that in our industry, I've personally witnessed large and small company personnel vent refrigerant. There's little or no enforcement of existing laws, so our government has declined to or decided to reinvent the wheel instead of enforcing the existing rules. What's your take on
Yeah.
that, Jake?
I mean, I get it, right? There's frustration from a lot of people, and it's some of it makes sense, and some of it, I mean, may not make sense in the way we do things. Yeah, like venting, right? I get that. I think they're thinking that the industry is thinking from a safety standpoint when it comes to that, right? So if we do have a leak, right, in the system, we want to vent it out versus the alternative, right, which is things could go a different way. So I think that may be one of the reasons why. But yeah, I understand that. I get that a lot, Jeff, when I do these presentations. It's you know it's I I'm trying to figure out how to say these things, right? But it's difficult for everybody in the industry, right? I don't think manufacturers, they want to go along and do it, but it costs them millions and millions and millions and millions of dollars to tool up and retool and then to go through this again, very, in a much sooner time frame, right, is going to cost a lot of money as well. So it's tough on everyone, that's for sure.
Definitely a
But we're
challenge.
trying to do the right thing from an overall perspective. We're trying to do the right thing, right?
Absolutely. From a time standpoint, Janine had a comment. She's echoing William's point. Do you have time for just maybe another question or two? It's 11:32 Central.
Sure, absolutely, Jeff. Not a problem.
Okay, so Dalton asks, what's your take on A2L refrigerant for cross-border companies? What are other manufacturers doing? The USA cannot produce 410A equipment after this year. You also cannot import 410A equipment. Canada does not have any adoption of A2L to date and will seemingly require 410A equipment beyond 2024 and 2025. Any thoughts on that for our
Yeah.
Canadian friends?
No, I don't. Unfortunately, I don't. I couldn't provide any input on that question. It's a valid question. It's one I really haven't thought of too much, right? I'm selling equipment down here in the Southeast and not to Canada, so it doesn't affect me. That's a great question for maybe manufacturers and some other industry leaders from that standpoint, but wish I could answer that a little bit better.
Well, and they can always get water source heat pumps that are in stock. So we do have some advantage there.
We do have
For
some
sure.
advantage there. That's correct.
Great. All right. Well, thank you again, Jake. This was a fantastic presentation. I think we all learned a lot. It will be recorded, should be up on the Expo website around Tuesday or Wednesday timeframe. I hope everyone has a great weekend, the Memorial Day holiday, and check back for more of these webinars. Thanks so much, Jake.
Thank you, Jeff. Appreciate it. Everybody have a safe weekend, and thank you to everybody who's served our country. So thank you very much.